Okay, for some reason it wouldn't let me unpause it while I was in the PowerPoint stuff. Alright, this is the first chapter and it should be an overview of PLCs. I'm not sure exactly what the chapter name is, but we're going to look at an overview of PLCs. So we're going to look at the history of the PLC. Okay, so we are going to look at the history of the PLC. We're going to look at the difference between a fixed and a modular PLC. We're going to talk about processors. We're going to talk about memory, which is RAM and ROM. We're going to talk about types of those memory. And then we're going to talk about the major components of the PLC. The main two things for this lesson are the fixed and modular and the major components of the PLC. So pay real close attention to those. All right. The PLC was introduced in 1960. Most of you were not born and not even thought of. Some of your parents were probably not even born. So it has been around a long time. The PLC is just a computer. It is a computer that controls control devices. So it controls motors, conveyors, it can control robots. A robotic controller is a type of PLC. Basically, the PLC replaced a lot of the motor control logic. So if you look around this room, we have motor control trackers, and on those you'll see push buttons and all kinds of switches and things like that. We used to have to do with wiring. Now with this, we can program it. Why would we change over to a PLC and get away from some of the motor controls? I can control it from one location. I can, if something happens in the plant, I can be at home and dial in through or remote in through my computer, and I can look at what's going on. I don't have to physically get out of my house and go to the shop. They don't have to wait on me to get dressed. I can look at it from where I am. Now, I might not can fix the problem, but I might can tell them exactly where the problem is. Okay? So there's a lot of reasons why you would want to change. It's cheaper. If I'm going to replace a whole bunch of relays and push buttons with a PLC, then that's hardware I don't have to buy. I buy one computer and it does all of the relays and control. It takes the place of all the control relays, a lot of the switches. Still got to have an e-stop. You still got to have a way to start it. But after that, we can replace a lot of it with the PLC. Timers and counters, all of those are replaced with the PLC. PLC can count. It's a computer. It's pretty smart, so it can count. I don't need a counter to do that for me. And I'll show you some of those devices shortly. A basic PLC consists of, and what I tell you need to make sure that you paid attention to, the components of the PLC. PLC consists of a CPU, which is the brain, okay? A CPU, a power supply, an input module, an output module. 4 things. So what are the 4 things that consist of a PLC made of? What's the 4 things? Very good. And you don't even have to say modules, just say input and output, and that's fine. All right. We have 2 types of PLC. We have fixed and we have modules. This is a fixed PLC. I'm going to pass it around. Okay. These are actually our newest ones. We just purchased these. This one is actually kind of a hybrid. They didn't used to have these years ago, and I don't know if I have a true fit with me, but I'm going to get one. But basically, this is a fixed PLC, but in this case, it's expandable. It has a little port right here that I can connect into to add additional ports. But with a fixed PLC, if you have, it would look like this without this expandable port. But basically, what the number of inputs and outputs that you have on a fixed PLC or the number that you have. So if I go buy a PLC and it has 8 inputs and 8 outputs and it's a fixed, and I need to add 9 things to it, I'm out of luck. Okay? It handles 8. 8 is all it'll handle. Okay? So this is basically the next PLC. This is the very old modular PLC. Okay, if I went and bought this PLC, and I buy it with 8 input modules and 8 output modules, then you get it screwed up with that. Okay, so you have 8 input modules and 8 output modules. Now, I got these PLCs when I learned them. So we have 8 and 8. But if I need 16 input modules, I just go buy a module. Pop it in there, and now I've got 16 input and 8 output. So this is a modular PLC. This means I can add ports to it. I can add cards that will expand it. Okay? So here comes this guy. The extra box does not really come with it. This was what we added to the PLC before this is just a switch and push buttons and lights.
So what is the GE is stand for?
GE is General Electric. They don't really make PLCs anymore. They don't want to do the around this is GE. It is not fixed this modular. I don't know why it is a modular PLC. The Allen Bradley 1500 is a fixed PLC. This guy is modular and it is the GE Series 1. So there we can that. Was that in there correct? Okay. Questions on fixed and modular? Okay. Guys, these are out on Blackboard, so you don't have to write down every word that's here. PowerPoint is on Blackboard. I don't want you to have to write down everything and not listen to what I'm saying. I actually had a student that did that. And he couldn't remember what my lectures were about because he's too busy writing everything that was up here. That's why the PowerPoints are out there. So you can go look at them. You don't just listen to me and anything I say that you think you need to know that's not up here, write it down. Okay? I need to change that. So I would suggest what you write down right now is that GE Series 1 is modular, not fixed. Just because I made a mistake. Some of you will be working on Allen Bradley SLC 504. The 504 is module. Some of you will be working on the Allen Bradley MicroLogic 1500. The 1500 is fixed. I'm probably going to, no matter what PLC you have, you're going to have to do one on the other PLC. And the only reason I'm going to make you do it is because they program differently. And you need to see how they program. Okay? So, I want to make sure that you know which one's which. Alright, so the CPU is the brain, it's the microprocessor. In your computer, you have a microprocessor, right? You know what your microprocessor is?
No.
It's either an Intel or a AMD. I mean, usually. And that is your CPU. It basically is going to take care of all instructions. So if I tell that thing to turn on the light in 10 minutes after I flip a switch, that's what tells it to do it. Okay? It executes all the commands. Memory is where I'm going to store what I want to tell it. Okay? It also has support chips, don't worry about that. We basically have two manufacturers of the CPUs. We have Intel and Motorola, and actually AMD. AMD doesn't make a lot of them right now for the PLCs, but they are starting to come up in, so I want to mention them while we're here. Alright, if we look on page 14 and 15, there's quite a bit of history for PLCs. It's going to go through, it still does like it used to do. Okay, so I have added AMD to the list now. And the history's on 14, 15.
Page 4.
That's on 16.
Well,
AMD, Intel, and Motorola is over on 6.
Okay. Yeah, they've got the history of the processor on page 16 now. That's why I think they had that all this information on the other book. So, I could go back and tell you how old I am and tell you what my first computer was, but we're not going to go there. So, basically, there's a lot of information in here on the history of the processor. Which this is not a computer class. I'm not getting into that. Okay? But it is there. If you're interested. The ALU is part of the processor as well, and it is the arithmetic logic unit. It is what does the math. It adds, subtracts, multiplies, divides, and it uses registers to store any of the information that it needs to store for those math functions. In this class, we're not going to go through math functions. I believe math functions is either chapter 10 or 11. Okay? That will be covered in PLC 2 if you want to take it. And PLC 2 will be offered, I believe, in the spring. So, do I don't remember. But it is offered in the spring, I believe. So if you want to take PLC 2, you're more than welcome to. Okay? But we don't do math functions in this class because it's a little more advanced and we have a lot of other stuff we need to get through. Alright, we have two types of memory. We have RAM and ROM. Okay? if you have a computer and you have gone to purchase memory, or somebody tells you you don't have enough memory in your computer, chances are it's RAM. Okay? RAM memory is read-write memory. It is, you can access it, you can read from it, write to it. So that means if I go in and open Word up and I make changes, I can save it into RAM. When you save a document, or when you open a document, it's in RAM. When you save it, that's not where it is, okay? Because when you turn the power off, you lose everything that's in RAM. That's why if you've ever shut down your computer, you've got things open and it says, are you sure you want to do this? You're going to lose all changes to any open files. That's because right now it's only in RAM. And if you kill the power, it no longer knows what's there. Okay. Now, your hard drive is of course where you store things when you save them. Okay. I use the example that RAM is like your countertop, and the hard drive is like your cabinet. You don't put food on your dishes while they're in your cabinet. You move them to the counter, use them, wash them, that would be kind of like save them, and put them back in your cabinet. So that's kind of the process. So you have to have it in RAM to work with it. So RAM is basically used only for temporary storage. Okay. Now ROM, on the other hand, is your BIOS. Some of you don't know what your BIOS is. That's actually what runs your computer. It tells it what it needs to do, or firmware, if you've heard of that term. It's kind of a cross between hardware and software. Basically, it's programs, but they're permanently saved. So when you turn on your computer, you don't have to tell it every time what it needs to do. If you've ever lost your clock battery on your computer, which doesn't happen quite so much anymore because much better batteries than we used to have. But if you've ever lost your clock battery, then what happens is your computer will come up and basically tell you it don't know when it is, so it can't boot. So you have to put a date and time into it, and then it'll boot. That is because it is losing its ROM, because the battery backup is not holding the information correctly. But ROM is basically more of a permanent storage. It is usually one chip or a few chips. And I don't know if I have a ROM chip in here. I should have. Let's see one. Okay. I don't really see one, but if you ever open your computer and lose your motherboard, there's usually a chip on there that has a piece of tape over the top of it, or a white label or something like that. That's your ROM chip. I'll try to find one and show you, but we've moved some stuff around and I'm just not sure where we have stuff stored. But basically it's a IC chip that would look something like this guy. Okay. Except that in the center right here you have a circle and you can actually see the chips in it. That's where they created it. And what you do is you take it and put it in, this device right here is a ultraviolet, and it will erase it. And then I have a programmer somewhere around here that, in this program right here, then you reprogram it. Okay. They also have some now though that are electrically changed. So if you ever updated your BIOS, you can actually flash your ROM. If you've ever heard somebody say they flash updated or done a flash update, that's what you do. You electrically erase it and put a new one in there. This is what we used to have to do years ago. This was our eraser and that was our reprogramming. And notice that we're not in that chapter yet, but notice that it's 0 through F. So that's in hex. So it's coded in hex. So you have to know your hex code. I won't pass this around. I'm not going to pass around the program. No, we will not. We don't even have to have that anymore. Most of the time, though, now the ROM comes from the factory. I mean, well, it always did. The ROM comes from the factory already programmed, unless you purchase it special. We have two types of RAM. Okay, we have static and we have dynamic. Okay, the basic difference between the two is static is much slower. I'm sorry, static is much faster, and all right, let's try this again. There we go. All right, static is more expensive. So the way I remember that, see, I spelled static. So it's a lot more expensive. It is faster, but it's a lot more expensive. Dynamic is slower, but it's a whole lot cheaper. So when you go to the store and you buy memory for your computer, guess which one you're buying? The dynamic. You're buying the slow stuff. Okay. But I can assure you, if you bought that much memory of the static, you couldn't afford it. It is a whole lot more expensive. The processor, when you buy a processor now, you have cache memory that comes with the processor. The cache memory is the static. So that's what kicks up the price of the processor. It's not as much the processor that's costing as much as it is the static memory that comes along with it. Everybody okay? Okay, we kind of talked about this, about it being firmware. It's not really software. It's not really hardware. It's a program inside, stored inside of a piece of hardware. So it's stored inside of that chip, and it's kind of permanent. So that's why they call it firmware. Somewhat permanent. So we basically have several of these. We have ROM. ROM means read only. You can never reprogram it. Even with my stuff over here, my old stuff, you can't reprogram it. It's not designed that way. It's designed to have the information in there one time, and that's all you get. You can't update it, nothing. Then you have PROM, which is program once, and we used to call it program once, read many. You can read it as many times as you want to after you program it. But once you program it, it is set. You cannot erase it and redo it. So if you make a mistake, you didn't want to make a mistake. But if you made a mistake, you threw that chip away. when I bought another. Because you could not reprogram it. Then we went to EEPROM, which is erasable using ultraviolet light, which is the little eraser that I just sent around. Now we have, and actually UV is the same as EEPROM, so both of these two are basically the same thing. Now, most of your computers have the electrical erasable. It's erased using electric current, and you can flash it. This is also called flash ROM as well as EEPROM. And these last three can be erased and reprogrammed as many times as you want to. So in class, when we were taking that class and learning how to program those, which one do you think they gave us? They gave us this guy. Okay, so we erased it with ultraviolet light, and that's on top of it, so they know it would get erased by ultraviolet light. So if you opened up your PC and we're under some ultraviolet lights, and it didn't have a sticker over the top of it, you'd pack it back up, put the screws back in, turn it down, and it'd have nothing. So that's why they put the tape over the top of it. It used to be black tape for that purpose, to make sure that it won't let any light through whatsoever. But now they just put a sticker over the top of it. But basically that's what we used. All right. Yes, sir.
EEPROM and UV
Same thing. They're identical. Just two different names. The address decoder, the microprocessor can talk to one device at a time. So we're going to kind of play a little game here. Okay. If you have this marker, you can talk. This is the way the PLC does. So only one person is allowed to talk. Okay, so that's how that works. PLC would only let one person talk at a time. It's like it has television. And it can look at one person and have one person talk to it. And that's it. If it's talking, nobody else can talk. And if I give you the floor, you're the only one that can talk. Okay? So that's how that works. And basically, I just explained that whole slide by a real quick demonstration. We have discrete input modules. Those are the modules on this G Series 1 that I showed you that we can pull in, plug in and out. The input modules basically come in 4s, 8s, 16s, and 32s. That's because it's binary. Okay, so binary has 2, 4, 8, 16, 32, 64. Everything's binary. And we'll talk about that shortly too. But input modules are usually octal transceivers. You don't need to know that, but if you're in industrial electronics, that might be something you hear later, so I just left it in there. There are some AC input modules. They're analog, and for the PLC to read them, they're going to have to be converted over to DC. So it uses a full wave rectifier. It uses an optocoupler to prevent voltage spikes, and it basically opto coupler is, has an LED and a photo transistor. And again, if you're in industrial electronics, that will interest you. But we don't have to know it in here, so I'm continuing on. Okay. We have discrete output modules. The PLC, it receives the signal from the PLC. So if I push a button, that button signal goes to the PLC. The PLC decides what that means. And then when it decides what that means and who it needs to talk to, it sends a signal. So if I want to turn that light on, I'm doing it very slow. I push the button. PLC says, okay, the button's closed. Now what do I do? And now it goes out and says, okay, output 5 needs voltage. So I'm going to send voltage out to output 5 to turn on the light, or turn on the motor, or turn on the switch, turn on the, whatever it is, the conveyor or whatever you have to hook up to. Okay? If it, it'll do the conversion of the signals for you, so you really don't have to worry about a lot of that in here. But it's going to convert any digital signals to analog when it needs to, and it's going to send an analog signal and then convert it back to digital when it needs to. Every output module, again, is based on on binary, so they are 4, 8, 16, and 32 ports. The output modules usually use octal latches, and we're going to talk about octal in a few minutes. Digital signals have to be converted to analog. Again, an optocoupler is used to prevent voltage spikes, and triacs are used as electronic relays. Again, industrial electronics. We also use line conditioners to prevent spikes. We have transformers that split, decrease, or increase voltage as needed. We can convert the AC to DC using a rectifier. Most of this is built into a power supply. If you have a computer, again, I know I keep going back to computer, but what is a PLC? A computer. So if you have a computer and you've seen the box in the back where the power cord goes in, that is just a power supply, and it takes AC voltage from the wall, and it using transformers and rectifiers and diodes and Zener diodes and electronic devices. It takes that signal, makes it exactly the voltage that it needs, and takes it from AC, which is a sine wave, to straight DC, which is nice and solid. So basically, that's all that is. All right, I got a lot of terms on here. Don't worry about all these terms. Okay, if you look on page, at the end of this chapter, I'm not even going to try to send this page. Look at the end of this chapter. Look at page 28. Obviously, we're not going to turn it in Monday. I can take that off, but that's why. That one is really bad. You should do much better reading that stuff now. Alright, questions number 3 and 4. Please answer those for me. Not right this minute, but please answer those for me.